Hi, this is Loki with Blue Collar Prepping. Last week, when I was describing the wiring method for making a 12-volt portable power box, Erin had some questions. She said, I understand a series circuit, I understand a parallel circuit, but you can do a combination circuit? So I told her I'd break it down a little bit. And so let's start with, for those who don't understand the electrical theory, what a series and a parallel battery setup is. So let's start with series. Now, the red is the positive terminal of the battery, the black is the negative, just like the car battery in your car. In a series circuit, you tie the negative from one battery to the positive on the other battery, and then your load ties to the positive on one battery, the negative on the other battery. What this accomplishes is this actually doubles the voltage available for that battery system. The most common that you'll see in your world is a 2-cell pocket flashlight. You put those batteries in and you got the positive end with a little nub on it on one side, and you got the flat side on the other, and run the other battery in just the same way. And two 1.5 volt AAA, AA, whatever cell batteries become 3 volts of power. And that's just the way that works. That's the most common thing you're going to find as a tool like that. Now, a parallel battery setup, you tie the 2 positive terminals together and the 2 negative terminals together, and then your loads go to the positive and negative, or to the load and the ground, however you're wired up. This is seen in things like large pickup trucks. My diesel truck has 2 batteries wired in parallel. My camp trailer also has 2 batteries wired in parallel. What this accomplishes, the voltage remains the same. I still get 12 volts when I measure where it ties to the load, but I double my amperage available to me. It's great for heavy loads. Diesel trucks run high compression. They take a lot of energy to start. My trailer, it doubles my available power if I'm out in the sticks and don't have a cord, can't plug in shore power. Now with this, if I lost one battery in my trailer, I could still have 12 volts. I would have half the amperage, and therefore I wouldn't last as long, but I could still get home. It may or may not start my truck, because my truck takes a lot of power to get started, but the potential is there. Now the combo setup, what we do is we wire this side. Think of these as 2 separate battery packs. So the top one and the bottom one are both wired in series. Got the negative on the one to the positive on the other, and then the load and the load. So that gets me, if these are 6-volt batteries, like I mentioned, 6-volt dry cell, lightweight batteries, that means that this gives me 12 volts. And the batteries I mentioned, they happen to be 4.5 amp hour batteries, so I would get 12 volts at 4.5 amp hours. That's not enough time, as I mentioned, to run my CPAP machine all night with the losses to the inverter, and that it won't get me enough time on the machine or on anything else I want to run. So if we take a second set of 12 volt 6 amp hour battery pack and we wire that in parallel, where you notice the positives are tied together and the negatives are tied together, now I have a 12 volt system that's generating 9 amp hours, which will get me plenty of time to run my CPAP for an entire night, or fully charge a tablet, a cell phone, any piece of electronic equipment you need to charge or run. It would run possibly an oxygen concentrator, any kind of equipment like that that is critical and needs to be runnable. And with those batteries being approximately 2 to 3 inches by maybe 4 inches max, they'll fit in a fairly compact container, something ammo can sized or similar, and the whole assembly weighs 10 to 15 pounds. Very light, very inexpensive, but that's how that wiring is done, such that you get a full 12 volts to run a proper inverter, but you get enough amp hours to get useful work out of it.